Hello everybody, I would like to welcome you to our 18th video in the pre-algebra playlist, and in this video we're going to go over the second part regarding solving inequalities. So in the last video, I said that there is one more step or something that's basically a little bit more complicated when it comes to solving inequalities regarding multiplication and division. But that only applies if the inverse operation of multiplication and division that you're performing involves a negative. If it involves a negative, you basically need to flip the sign when you perform that inverse operation. So what do I mean by that? Well, first let's go over the multiplication property of inequality and the division property of inequality, and then once you get the hang of that, we will do plenty of examples so you know how to solve inequalities no matter how hard they are. So in the multiplication property of inequality, there are basically four scenarios that we need to go over. So in the first scenario, let's say I have some number A that is less than some number B, and I have some number C. If C is a positive number, then if I multiply C to both sides of this inequality over here, I get A times C is still less than B times C. Similarly, if I have some number A that is greater than some number B, and I have some number C that is again a positive number, the product of A times C will still be greater than the product of B times C. On the other hand, if I have some number A that is less than some number B, and in this case the number C is a negative number, then the product of A times C will not be less than, but it will be greater than the product of B and C. Similarly, if I have some number A that is greater than some number B, and I have some number C that is again a negative number, then the product of A times C will not be greater than, but it will be less than the product of B times C. And the same rules apply if you have less than or equal to, or greater than or equal to, or anything like that as well. Now let's go over the division property of inequality, where there are four more scenarios. So for the division property of inequality, let's say I have some number D that is less than some number E, and I have some number F that is a positive number. Then if I divide the inequality D is less than E by the number F, I will get D divided by F is still less than E divided by F. Similarly, if I have D is greater than E and I have some number F that is again a positive number, then D divided by F will still be greater than E divided by F. But again, when it comes to F being a negative number, let's say I have D is less than E and F is a negative number. Then D divided by F will be greater than E divided by F. Also, if I have D is greater than E and I have some number F that is again a negative number, then D divided by F will be less than E divided by F. And the same rules for the division property of inequality apply if you're left with D is less than or equal to E, or if you're left with D is greater than or equal to E. So basically, what all of this means over here is that when you're dealing with a negative number, especially when it comes to multiplication and the division of an inequality, you really need to flip the sign, or basically reverse the order of the inequality. Now let's do about 4 examples where we actually solve inequalities dealing with multiplication and division, and then by that time you'll get a better understanding of how to solve inequalities involving multiplication and division. So in this first example, let's say you're left with the inequality 2x minus 7 is greater than or equal to 21. Now the first thing that you do is figure out some way to get the variable x all by itself. And in order to do that, you need to follow the reverse order of PEMDAS that we went over in the solving equations portion of the video series. So the reverse order of operations, or basically the reverse order of PEMDAS, is known as the SAD MEP. Now SAD MEP is something that I came up with all by myself, and you probably won't be able to find it in any textbook. So the first thing that you need to do in order to get the variable x all by itself is to get rid of all the subtraction or addition on the side of the variable. In this case, I need to get rid of the subtraction, or basically the negative 7 term on the side of the variable. So in order to get rid of the negative 7, I need to perform the appropriate inverse operation of adding 7 to both sides of this inequality. And when I do that, I get 2x minus 7 plus 7 is greater than or equal to 21 plus 7. When I simplify my left-hand side of this inequality, I get simply 2x, which is greater than or equal to 21 plus 7, which is 28. Now the appropriate inverse operation of multiplying 2x is dividing both sides of this inequality by the number in the front of the variable x. In this case, the number in front of the variable x is known as the coefficient, which is the number 2. So all I really need to do is divide both sides of this inequality over here by the number 2. And when I do that, I get 2x divided by 2 is greater than or equal to 28 divided by 2. These two 2's cancel each other out to give me a 1 as the coefficient, which is what I'm looking for. So I'm simply left with the variable x, which is greater than or equal to 28 divided by 2, which simplifies to 14. So the solution that satisfies the inequality 2x minus 7 is greater than or equal to 21 is x is greater than or equal to 14. In this example, let's say you have the inequality negative 3y plus 4 is less than or equal to 16. Now we need to follow the order of SAD-MEP in order to isolate the variable y in this inequality over here. Referring to SAD-MAP, we know that the first thing that we need to get rid of on the side of the variable y is the addition. In this case, we need to get rid of the plus 4 term safely so that we preserve the inequality that we started off with. So the appropriate inverse operation that will get rid of plus 4 is to subtract both sides of this inequality by the negative 4 term. When I simplify the left-hand side of this inequality, I simply end up with negative 3y, which is less than or equal to 16 minus 4, which is simply 12. Now here is what I have been talking about all this while. When you perform the inverse operation of division or multiplication when it comes to the inequality, and if that number has a negative sign on it, then all you really need to do is perform that inverse operation and then flip the sign of the inequality. So what do I mean by that? Well, the appropriate inverse operation that will give me simply y on the left-hand side of this inequality is to divide both sides of this inequality by the number negative 3. Now, the negative 3 on the top and the negative 3 on the bottom will cancel each other out to give me a positive 1. And this makes sense because a negative number divided by a negative number will give me a positive number. So I'm left with only the y on the left-hand side. Now, the only tricky part that you need to remember is that once you simplify, you need to flip the sign over here. So instead of reading it as y is less than or equal to, you read it as y is greater than or equal to. And then you simply evaluate 12 divided by negative 3 to give you a negative 4. So the solution of the inequality, negative 3y plus 4, which is less than or equal to 16, is the inequality y is greater than or equal to negative 4. In this example, let's say you have the inequality 4x divided by 9 is greater than negative 20. Now, referring back to the solving equations portion of the video series, I know that if I want to get rid of the denominator, all I really need to do is multiply both sides of this inequality by whatever the denominator is. In this case, if I multiply both sides of this inequality by the number 9, I will end up with whatever's on the top of the division symbol, or simply 4x. When I evaluate that, the 9 on the top and the 9 on the bottom cancel each other out to give me a 1. So I'm left with 4x is greater than negative 20 times 9. And negative 20 times 9 will give me negative 180. So the next step that I need to do to isolate the variable x is to divide by the number 4. I get 4 divided by 4, which will simply give me a 1, and 1 times x will simply give me an x. And then I get x is greater than negative 180 divided by 4. And negative 180 divided by 4 is negative 45. So in this example, let's say you have negative 11y divided by 2 plus 2 is less than 244. So first I write down the sad map mnemonic right over here. And then I realize the first thing that I need to get rid in order to get the variable y all by itself is the addition term. And the addition term over here is the plus 2. So the inverse operation of plus 2 is subtracting both sides of this inequality over here by the number 2. So now these two terms over here cancel each other out to give me a plus 0, or more simply negative 11y divided by 2, which is less than 244 minus 2, or simply 242. The next thing that I need to do is get rid of the denominator on over here. Now you saw in the previous example that all I really need to do is multiply both sides of this inequality over here by the denominator. So these two 2's over here will cancel each other out to give me a negative 11y is less than 242 times 2, which is more simply 484. So the next thing that I need to do is realize that I have negative 11 times y. And the appropriate inverse operation of negative 11 times y is to divide both sides of this inequality by the number negative 11. These two negative 11's will cancel each other out to give me a positive 1 as the coefficient for the variable y. So I'll be left with only the variable y on the left hand side of this inequality. Now since I performed the inverse operation which involved a negative in itself, I need to flip the sign of the inequality over here. So the less than inequality becomes a greater than inequality. And when I evaluate 484 divided by negative 11, I get negative 44. So that's it for this video, and I hope you learned a lot from it. I hope you keep on working hard, and I'll see you in the next video.